Good morning, learners and viewers. Welcome to the session of Maintenance Management MMPO 007. Today we will be talking about Unit 11, that is Condition Based Maintenance, CBM. Maintenance is a routine and recurring activity of keeping a particular machine or facility at its normal operating condition so that it can deliver its expected performance or service without causing any loss of time on account of accidental damage or breakdown. In general, maintenance is defined as all the actions taken during the operation stage of a machine to ensure that it continues to function as per expected standards or even better. It also encompasses those actions which prevent the machine to lose any of its functionality or, in other words, prevent failure. Such actions or the maintenance policies in general can be categorized into various types. We see over here that it can be maintenance strategies, breakdown corrective maintenance, productive or total productive maintenance, and preventive maintenance can be time based and condition based. Now, what is condition based maintenance and condition monitoring? Condition based maintenance is a maintenance technique that involves monitoring machine condition and predicting machine failure. Unlike periodic maintenance, where services are based upon scheduled intervals, CBM relies upon actual machine health to dictate when and what maintenance is required. In simple words, we can describe CBM as direction of machine maintenance actions based on indication of assets health as determined from non-invasive measurements of operation and condition indicators. CBM allows preventive and corrective actions to be optimized by avoiding traditional calendar or run-based maintenance. Condition-based maintenance is based on condition monitoring. According to a time-based maintenance policy, if too short a maintenance interval is selected, the machine may be overhauled unnecessarily, with consequent loss of production and possible human errors during inspection or reassembly. Generally, failure is the culmination of slow deterioration over a period of time. An acceptable compromise is to perform maintenance at irregular intervals, determined by the actual condition of the equipment. To establish these intervals, the actual condition as well as the trend of deterioration over a period of time must be known. A procedure on these premises is known as condition monitoring. Condition monitoring is monitoring of operational plant and analysis of data obtained to detect incipient faults and predict the residual life for safe operation. Condition monitoring falls into two distinct classes. First one is monitoring, which can be carried out without interruption to the operation of the equipment. That is online monitoring. And the second one is monitoring which requires shutdown of the unit or releasing it from its prime duty, that is offline monitoring. The limitation of time based maintenance policies over condition based maintenance are the optimum interval of time based maintenance is greatly influenced by the reliability on data input, such as failure distribution, cost of maintenance, as well as failure, etc. The accuracy of estimating maintenance interval is low in most of the cases, as it is very difficult to correctly estimate the ratio costs incurred by a preventive replacement before failure to the cost incurred when breakdown maintenance is taken up. Time based periodic maintenance increases the probability of introducing a fault while carrying out maintenance work. These limitations of time based preventive maintenance are taken care of by preventive maintenance or condition based maintenance, which aims at reducing breakdown and accident caused by equipments, increasing operating time and production, reducing maintenance times and costs, and increasing the quality of products and services. Condition based maintenance may result in average saving of 20% of direct maintenance cost, besides increasing production by 100%, and that was proposed by Dalton in 1987. Now, how to implementing conditions based maintenance? The criteria to be considered while implementing condition based maintenance are summarized as existence of a prognostic characteristic. Secondly, availability of instrument that can measure the value of prognostic characteristics, that is measurability. Third one is predictability of equipment failure based on the value of the prognostic characteristics. Fourth one is availability of skilled personnel to carry out condition monitoring. Fifth one is failure rate of the equipment under consideration is not too high. And the last one is cost effectiveness. Implementing condition based maintenance in a typical industry calls for few steps. First one, selection of critical machines on which conditional monitoring has to be carried out. Secondly, selection of an appropriate prognostic characteristics and setting its limits. Third one is selection of appropriate measurement tools or conditional monitoring method for each critical machine. Prepare a schedule of condition monitoring program and collection of data, recording and processing, including trend analysis, and repair, replacement, or other type of maintenance activity based on condition of the machine. Now, how selection of critical machine is done. Following guidelines are found useful in identifying the critical machines in a plant. First one is part of a continuous process, parts of a single production line, equipment without standby, parts of production line without intermediate storage capacity, parts of a line transferring dangerous fluids, machine operate at high temperature, pressure or voltage, and machine containing high inertia, high speed components, and machine arranged in very compact layout with high maintenance cost. The criticality index of a system is often used to determine the type of condition monitoring solutions that need to be applied to the equipment. And this index depends on the following factors: economic impact due to an unexpected stoppage, cost of repair, and environmental impact due to a stoppage, and impact on security of staff. What are the methods of condition monitoring? Condition monitoring starts with basic inspection. Small changes like abnormal heat or pressure, strange sounds, excessive vibration, or a different smell are often signs that something is going awry. However, condition monitoring techniques vary from the simplest inspection to cutting edge technology. And there are nine types of condition monitoring methods, that is oil analysis, vibration analysis, motor circuit analysis, thermography, ultrasonic monitoring, radiography, laser interferometry, electrical monitoring, and electromagnetic measurements. Now we start with oil analysis. Oil analysis implies to machine oils, lubricants, and fluids. It can detect wear, overheating, and contamination. High levels of iron, for example, often indicates dirt and grit. Spotted on time, this reduces gearbox failure by 50%. Avoid contamination decreases bearing failure by 75%. A Canadian study suggested that the return on investment for oil analysis is 20 is to 1. There are several oil analysis methods available for preventing these kinds of failure, such as ferrography, water presence test, viscosity test, ICP or spectrography, dielectric strength test, and microbial analysis, etc. Now we move to block 4, that is issues in maintenance management. It starts with sustainability and safety. The impact of industrial and manufacturing system on energy and resource use, environmental emission, and society is significant. Sustainable manufacturing is a crucial concern that must be addressed to achieve sustainable development in our society. The maintenance process plays a crucial role in ensuring equipment availability, dependability, and safety, which is essential for sustainable operations. Ensuring proper maintenance is crucial for preventing the value of assets and attaining the desired level of performance. Nevertheless, maintenance plays a crucial role in ensuring and preserving a secure and conducive working environment for both the individuals within the manufacturing plant and those in its vicinity. Maintenance of equipment and other systems plays an important role in eliminating failure and losses. In order to correct or prevent any kind of menace, or a good sustainable maintenance strategy and practice needs to be adopted. Some futuristic organizations understand the importance of the safety. The objectives of bringing safety and sustainability together are to eliminate accidents, waste, and overall losses, improve operational excellence, and conduct business in a sustainable way that protects human and natural resources and reduces the business environmental footprints. Elements of sustainable and safe maintenance practice. In order to enhance the ability of operations of equipment and reduce maintenance costs, researchers have proposed sustainable and safe management practices. The elements of sustainable management practices are digital record keeping. This is an essential element to sustainable and safe maintenance practices. Every activity on equipment and its component should be documented, and it is very important to keep this kind of database. Second one is prognostic tools. After the record keeping, there are certain tools that deals with the forecasting and predicting future component performance. These kinds of tools analyze the pattern of a normal day-to-day operating conditions and then assesses the deviation and failure extent of a component or an equipment. Diagnostic tools. The requirement of diagnostic tools rise when prognostic tool fails to predict the failure of the component or the equipment and the defects occurs. The tool works with the detection of defect, reason of the defect, and the possible timing of the defect occurrence. Diagnostic tool works on the basis of time series models as it helps in decision making. Technology monitoring equipment conditions. The technology used in monitoring equipment conditions can help in processing both the tools, prognostic and diagnostic. The technology monitors the acquisition of data, vibrating machinery, the analysis of oil, temperature of the equipment, and room temperature, pressure, and other factors that concerns the equipment health. Manufacturability. Manufacturing of the products can be achieved through different approaches and techniques applied in production and operating system. Some of these techniques are lean manufacturing, agile manufacturing, just-in-time automation, and Toyota Production System, that is TPS, Kanban, and several other conventional approaches. All these approach and technology can be formulated in a strategy. Then comes the functionality. This particular factor is based on the condition which is required to produce a product. The function of equipment and process is kept in the consideration in this factor. The products are different from each other, and some of the product requires more assistance, precision, and no compromise in terms of quality. The components of safety and environmental issues and their relation to maintenance management. There are various issues concerned with the safety and environmental performance of an enterprise. These issues are also linked to the operation and maintenance management function. These are corporate objectives and goals. The top management of the organization is expected to clearly specify the corporate objectives and goals it would like to practice regarding environment and safety or assurance. Many times, this is done through a widely publicized policy statement. The policy and objectives of the operation and maintenance functions are expected to dovetail them into the corporate safety and environmental objectives. What are the documentations of process and equipment? Another important requirement for the safety and environmental assurance of the company is the meticulous document of the vital specifications of the process and equipment in terms of their compliance with safety and environmental standards, statutory or otherwise. Risk management. As it may not be possible to eliminate the risk to zero level, specifically in the case of large complex process plants. It is would be required to scientifically analyze the risk involved and prepare plans to mitigate them. Risk management involves using multidisciplinary knowledge and participation of to identify all possible hazards and solutions to keep their risk at acceptable levels. Change management. In process plant, many environmental and safety failures arises from the failure to manage changes in the technology application and system. The Fluxboro accident happened due to the failure to manage properly the change required in terms of providing a bypass line to a reactor during the shutdown of the reactor. Human factors. The untrained or improperly placed worker will likely to commit mistakes, which may lead to safety or environmental consequences. Apart from this, other human factors like attitude, ergonomics, work culture, etc., have great bearing on safety and environmental performance. Investigation of incidents. There is requirement, statutorily or otherwise, to intensify, investigate accidents so that underlying causes can be found out and corrective actions for future improvement can be prescribed. Safety and environmental audits. As we have already discussed, there is an increasing tendency to integrate safety and environment audit requirements in the maintenance audits. The audits are mainly to identify whether the existing systems, techniques, and procedures comply with the stated and required standards and suggest improvements wherever required. Maintenance techniques for safety and environmental improvement. The primary function of maintenance management is to ensure plant and equipment availability. However, intrinsic to this requirement is the necessity to also provide maximum reliability and safety. Maintenance management needs to integrate their techniques to improve safety and environmental aspects of operation and maintenance of plants and equipment simultaneously. Classification of plant and equipment. It is normally required for the maintenance management function to classify the equipment into various categories so that resource allocation can be facilitated according to their criticality. Apart from the conventional broad factors of operational criticality, maintenance intensiveness, quality of products, it is emphasized that safety and environmental factors is also considered in such classifications. Preventive and predictive maintenance scheduling, regular checklist and prevention and preventive maintenance schedules should include important safety and environmental checkpoints. Nowadays, preventive maintenance is often supported by instrument oriented measurements, which is known as condition monitoring. Shutdown maintenance planning. Long shutdowns for annual turnarounds and significant overhauls are essential for many process plants and heavier and complex equipment. Due to tight schedule under which shutdown maintenance is executed, there are many possibilities of compromises on safety and environmental features and standards. Communication between maintenance and other departments. Many safety and environmental hazards have emanated from improper communication between the maintenance and the other department, especially the operations department. Maintenance training. All maintenance personnel working in plant facilities should be trained to understand the process and mechanical hazards. The training should include mechanical skills, theory, on the job, apprentice training, safe work practices, and specialized craft training. Maintenance staff often forgets after a period that the company often loses valuable work information. Several accidents have occurred due to such corporate memory lapses. The techniques useful under Such circumstances are refresh training of all staffs, use of incident investigation in training, publicity campaigns on safety, close supervision of new staff, safety compliance audits, and counseling poor performing staff. What are the types of maintenance strategies? The maintenance strategies are carried out in two manners: planned and unplanned maintenance. The planned strategies are the predetermined daily, weekly, monthly, and annual activities like cleaning, equipment, and plant. The unplanned strategies are which is done on emergency basis or when the fault arises. The type of maintenance strategies are corrective maintenance, preventive maintenance, predictive maintenance, and condition based maintenance. Corrective maintenance, it is necessary maintenance, which is done subsequently as soon as the machine breakdown and reflected as in state that can affect the manufacturing of the product. This is the simplest form of maintenance when where utilization of components takes place until its breakdown. This strategy covers the activities which involve the replacement of the defective component or repairing of the equipment. Second one is preventive maintenance. The preventive maintenance is used to cover the limitations of corrective maintenance by reducing the number of malfunction or failure incidents or any other cause of emergency. Preventive maintenance strategies is the approach where the time plan is ready for maintenance. There is a regular scheduled maintenance with specific time intervals for every machine. Then comes your predictive maintenance. Predictive maintenance is used to monitor and measure the performance and health of a component or a machine. The technology used in monitoring the condition of the component or equipment helps in predicting the status of the equipment in near future and therefore making better decisions. Condition based maintenance. This CBM is used when there is a change in the external environment of the machine, which ultimately affects the performance. The main ground on which this maintenance strategy is applied is the any kind of alterations happen in the condition of maintenance initiatives to achieve sustainable development, that is green maintenance. Now we move to initiatives to achieve sustainable development, that is green maintenance. Green maintenance is one of the initiatives which is applied in the industries. Cause effect analysis for elimination of serious failures. The strategic decision making process in terms of safety and cost minimization has become very complex. The cost effective analysis helps in identifying the risk and uncertainty coming in the future and thus helps in better decision making. Technical diagnostic tools supporting in providing regular monitoring of machine work parameters. If the planning is done on the basis of reliable operational data, the high level of technology driven service planning can be achieved. Similarly, the condition monitoring of production machines and components is important to streamline with sustainable management strategies. Overall equipment effectiveness, that is OEE. Three elements are used to measure OEE, that is availability, performance rate, and quality rate. The first element is availability. This is related to the ratio between the estimated operating time and actual operating time, where the managers observe unnecessary downtime, any changes in the condition, and so on. Second element is performance rate. This particular element measures the ratio between ideal speed of the equipment and actual speed of the equipment, and then highlights the discrepancy between the two speeds from which the performance of the machine can be measured. And the third one is quality rate. This element measures the ratio between the quality of the defective production and the total quantity production. Now we move to next unit, that is total productive maintenance. The component of productive maintenance was first noted in 1954 by General Electric Company USA. Productive maintenance effectively combines preventive, predictive maintenance, and maintainability improvement techniques with the principle of design to life cycle cost. Productive maintenance aims at balancing between two kinds of cost. On one hand, preventive maintenance needs strengthening to minimize the loss related to costs of equipment downtime. And secondly, too much cost cannot be incurred preventive maintenance. Total productive maintenance is a Japanese concept conceived by the late Dr. Takashaki, one of the founder of the Japanese Institute of Plant Maintenance Modernization. Of plant maintenance in Japan began in 1951 when preventive maintenance was introduced from America. In 1960, Nippon Denso Company Limited, part of Toyota Automobile Group, brought in the concept of productive maintenance, in which operators devoted themselves to production and the maintenance crew was responsible for maintenance. Before adopting total productive maintenance, Nippon Denso had been actively promoting automation of its production, such as part manufacturing and assembly. But as operations were automated, maintenance of the automated equipment by the conventional maintenance crew became possible. What are the characteristics of TPM? According to Tonkin, TPM is advocated to improve the whole production process. TPM encompasses a broad range of activities which are designed to improve equipment effectiveness in quality and performance readiness, that is availability, and involve all departments and function of the company from top management to shop floor people. TPM has three goals: zero breakdown, zero defects, and zero accidents. It is not a management technique, it is a corporate philosophy or culture which has two core components. First, focus on improvement of equipment effectiveness, and secondly, total employee participation in maintenance improvement. The main features of TPM, as given by Japan Institute of Maintenance in 1971, are: it is aimed at maximizing equipment effectiveness. It establishes a total system of productive maintenance covering the whole life of the equipment. It covers all departments such as equipment planning department, equipment usage department, maintenance department, and so on. TPM is participated in by all staff members from top management down to the shop floor workers. And it promotes productive maintenance through autonomous activities. The conventional preventive maintenance policies aims at profitable preventive maintenance through scientifically established maintenance schedules. American style productive maintenance calls for a maintenance plan covering the entire life of the equipment. TPM encompasses the above two beside its unique feature of total participation. The word total in total productive maintenance has three meanings. First one, total effectiveness. This is ensured by a scientifically established preventive maintenance system, taking care of the economic efficiency of the system. Secondly, it is the total maintenance system, which means establishing a maintenance plan for the entire life of the equipment. During the equipment design stage, it is pursued by the concept of maintenance prevention or maintenance free design. And the third one is total participation. This is unique to 2PM. Employee participation from top to bottom in small groups and autonomous maintenance by operators are the basics of total participation in total productive maintenance. Then comes your equipment effectiveness and six big losses. The predominant motive for the advocation and subsequent adoption of TPM, as designed by Takashi in 1981, was the adoption of the life cycle approach for improving the overall performance of production equipment. Equipment effectiveness is the product of three ratios. First one is operating rate, that is availability. Second one is performance rate and quality rate. Mathematically, these are expressions, so we can say that equipment effectiveness is the product of operating rate and performance rate and quality rate. And these three rates are expressed. Operating rate is operation time by loading time, where operation time is loading time minus downtime. Second one is performance rate. Performance rate is the product of net operating rate and operating speed rate. And the third one is quality rate. That will no doubt will be a ratio. Acceptable amount to processed amount, where acceptable amount is process amount minus defective amount. Ideally speaking, after successfully implementing TPM, one should be able to achieve availability of more than 90%, performance rate of more than 95%, and quality rate of more than 99%. Equipment effectiveness of over 85% is considered to be a significant achievement. In order to maximize the equipment effectiveness, TPM aims to eliminate the six big losses that interfere with effective operations. These six big losses are categorized into three classes. The first one is downtime loss, which includes breakdown. These losses are caused by unexpected breakdowns. Second one is setup and adjustments. These are the downtime losses due to the setup and adjustments, such as changing dies in press machines and injection machines and adjusting the equipment, etc. Second one is speed losses, which includes another two parts, that is idling and minor stoppage. Idling occurs when the equipment runs without producing for some reasons. Minor stoppages occur as a result of small problems which can be identified quickly, and normal operations can be restored easily. Second one is reduced speed. This is the loss due to the difference between the design speed and the actual speed of operations. And the third category is quality losses, which includes process defects and reduced yield. If we talk about process defects, these are the losses in quality of products caused by an equipment in terms of defects and reworking on these defects. The second one is reduced yield. This kind of loss is the quality loss during the stages of startup and stabilization of an equipment. Nakajima suggested measures to overcome the six losses. For breakdown losses, sporadic breakdown, which leads to function loss of the equipment, happens suddenly or unexpectedly, causing the equipment to come to a grinding halt. Reason for sporadic breakdown can be easily detected because there are one or a few obvious causes, and the remedy for this is restoration. Then comes your chronic breakdowns. On the other hand, are frequent and normally minor. They are of function reduction time and hence generally not taken seriously. Chronic breakdown occurs due to the combination of unclear causes. To uncover these hidden defects and eliminate chronic breakdowns, five measures are suggested. First one is maintain basic equipment conditions. Three factors are involved in maintaining basic equipment conditions. That is cleaning, lubrication, bolting. We should adhere to operating conditions. Running equipment at the prescribed operating conditions ensure optimum safety. Third one is restore deterioration. Apart from restoring the parts directly involved in breakdowns, it calls for restoration of deterioration in all other parts indirectly involved in the breakdown. Fourth one is correct decision weaknesses. Often, elimination of breakdowns is not possible because of problems caused by design weakness. These situations call for changes in equipment design. Fifth one is improve operating and maintenance skills. Extensive training and education in operating conditions and maintenance workmanship avoids human error, which are the cause of any breakdown. Second one is setup and adjustments. Setup improvements can be accomplished by distinguishing between internal setup and external setup. Internal setup should be minimized by converting it to external setup. Improvements in adjustments can be accomplished by adopting an industrial engineering approach. Only unavoidable and essential adjustments should remain. Third one is idling and minor stoppages. TPM way of reducing idling and minor stoppages can be summarized as correct slight defects in parts and jigs. Ensure that basic equipment conditions are maintained. Review basic operations in terms of operating standards, setup and adjustment procedures, and performances. Conduct physical analysis of phenomena of idling and minor stoppages. Adopt an analytical approach to find out the root cause of the phenomena of idling or minor stoppage. And sixth one is eliminate design weaknesses. Fourth one is reduce speed. At the outset, design speed should be compared with standard speed. Since many a times a design speed is vaguely set, which is never attainable. Minor defects, so far unnoticed or unattended, but become in the way of increasing speed, should be immediately attended to. Fifth one is process defects. Sporadic breakdowns causes process defects. Restoration is the method of correcting this problem. As in case of chronic breakdowns causing chronic quality defects, it should be tackled through investigation and innovation action. Sixth one is reduced yield can be minimized after critically examining their inevitability. Eight pillars of TPM. The principal activities of TPM are organized as pillars. Depending on the author, the naming and numbering of the pillars may differ slightly. However, the generally accepted model is based on Nikajima's eight pillar. You can see it is this total productive maintenance comprises of eight pillars, which are set on 5S. These eight pillars are focused improvement, autonomous maintenance, planned maintenance, early equipment management, quality maintenance, education and training, administrative and office maintenance, and safety, health, and environment. Now, since these eight pillars rest on 5S, now the question is, what are these 5S methodology is? 5S is a systematic method to organize, order, clean, and standardize our workplace and keep it that way. 5S is based on Japanese approach to establishing and maintaining an organized and effective workplace. The elements of 5S are Seri, which is related to organization, Sienton, which is orderliness, CSO, that is cleaning, Shikakatsu, that is cleanliness, and Shifsuku, that is discipline. The steps within the 5S process. 5S are sort, which means remove all items from the workplace that are not needed for current production. Set an order. Arrange needed items so that they are easy to locate and use. Third one is shine. Clean floors, equipment, and workstation. Standardize. Create methods and practices to maintain salt, set in order, and shine. And the last one is sustain. Make 5S an integral part of standard operating procedures. Autonomous maintenance pillar. Autonomous maintenance pillar is the process by which equipment operates, accept, and share responsibility with maintenance for the performance and health of their equipment. The driving concept Autonomous maintenance is the creation of expert equipment operators for the purpose of protecting their own equipment. Autonomous maintenance is the cornerstone of TPM activities. Autonomous maintenance has two aims: to foster the development and knowledge of the equipment operators and to establish an orderly shop floor where the operator may detect departure from optimal conditions easily. Second one is focused improvement pillar. This focused improvement includes all activities that maximizes the overall effectiveness of equipment, process, and plant through elimination of losses and improvement of performance. The objective of focused improvement is to ensure that equipments to perform every day as well as it does on the best day. The driving concept behind focused improvement, therefore, is zero losses. Maximizing equipment effectiveness requires the complete of failures, defects, and other negative phenomena. In other words, we can say that waste and losses incurred in equipment operations. Overall equipment effectiveness, that is OEE, is the key metric of focused improvement. Focused improvement is characterized by a drive for zero losses, meaning a continuous improvement effort to eliminate any effectiveness loss. Casual factor relationship for equipment effectiveness can be single a single casual factor for the effectiveness loss. Multiple two or more casual factors combined results in effectiveness loss. Complex, the interaction between two or more casual factors result in effectiveness loss. Minor or hidden defects results from a number of casual factors physical reasons such as contamination, dust, dirt, chemical leaks, etc. Invisibility to operators, excessive safety covers, and equipments not designed for ease of inspection. Second one is operator reasons, such as importance of visible defects not understood. Visible defects are not recognized. A number of tools are commonly used to analyze productivity losses in the focused improvement pillar. And some of these are Pareto charts, 5 Y analysis, fishbone diagram, PM analysis, fault tree analysis, and failure mode effects analysis, that is FEMA. Next one is planned maintenance pillar. The objective of planned maintenance is to establish and maintain optimal equipment and process conditions. As defined by JIPM, devising a plant maintenance system means raising output, no failure, no defects, and improving the quality of maintenance technicians by increasing plant availability, that is, machine availability. Implementing these activities efficiently can reduce input to maintenance activities and build a fluid integrated system, which includes regular preventive maintenance to stop failures, corrective maintenance, and daily MP to lower the risk of failures, breakdown maintenance to restore machines to working order as soon as possible after failure, and guidance and assistance in Yushi Hozon, that is autonomous maintenance. Quality maintenance pillar. Quality maintenance is in a nutshell is establishment of conditions that will preclude the occurrence of defects and control of such conditions to reduce defects to zero. Quality maintenance is achieved by establishing conditions for zero defects, maintaining conditions within specified standards, inspecting and monitoring conditions to eliminate variation, and execution preventive actions in advance of defects or equipment process failure. The core concept of quality maintenance is integrating and executing the structures, practices, and methodologies established within focused improvement, autonomous maintenance, planned maintenance, and maintenance prevention. Maintenance prevention pillar. Maintenance prevention refers to design activities carried out during the planning and construction of new equipment that imparts to the equipment high degree of reliability, maintainability, autonomy, operability, safety, and flexibility, while considering maintenance information and new technologies, and two, thereby reduce maintenance expenses and deterioration losses. To be specific, maintenance prevention design should be so done as to satisfy reliability, maintainability, issue horizon, operability, resource saving, safety, and flexibility. One of the goals of MP design is to break free of equipment centered design mentality by adopting a human machine system approach. Education and training pillars. The education and training pillars helps in imparting knowledge, skills for operating, and then increase skill level of operation personnel. It is aimed to have multi-skilled, revitalized employees whose morale is high and who are eager to work and perform all required functions effectively and independently. The different phases of skills are phase one, do not know. Phase two is know the theory but cannot do. Third one is can do but cannot teach. And the fourth one is can do and also teach. Policy. It focuses on improvement of knowledge, skills, and techniques, creating a training environment for self learning based on felt needs. Third one is training curriculum, tools, assessment, etc., conductive to employees' revitalization. Fourth one is training to remove employees' fatigue and make work enjoyable. What are the targets to be achieved? Achieve and sustain downtime due to want man at zero or critical machines, and achieve and sustain zero losses due to lack of knowledge, skill, techniques, and aim for 100% participation in suggestion schemes. Safety and environment pillar. No TPM program is meaningful without strict focus on safety and environmental concerns. Ensuring equipment reliability, preventing human error, and eliminating accidents and pollution are the key tenets of TPM. Implementing the TPM safety and environmental pillar focuses on identifying and eliminating safety and environmental incidents. On an average, for every 5 lakh safety incidents, There are 300 near misses, 29 injuries, and one death. Investigating industrial accidents, it is found that 88% of the accidents were caused by unsafe act of people. 10% were the results of unsafe physical condition, and 2% considered as acts of God. The cause is unknown. Environmental safety goes beyond simply eliminating accidents. In today's manufacturing environment, environmental safety includes reduction of energy consumption, elimination of toxic waste, and reduction of raw material consumption. TPM addresses the following key environmental objectives within the safety and environmental pillar. First one is to construct an environmental management system, that is EMS, that integrates environmental issues as a system. This objective is consistent with ISO 14001 and 14004. Implement activities through the TPM program reduces the environmental impact of manufacturing operations. Thirdly, it creates system to reduce the environmental impact of manufacturing, product and process development. Fourthly, enhances the environmental awareness and education of all employees. Office TPM pillar. Office TPM pillar applies TPM activities to continuously improve the efficiency and effectiveness of office functions. These support functions may have a significant impact on the performance of manufacturing production operations. Manufacturing is not a standalone activity, but is now fully integrated with and dependent on its support activities. These departments increase their productivity by documenting administrative systems and reducing waste and loss. Like equipment's effectiveness improvement, Office TPM focuses on identifying and eliminating effectiveness losses in administrative activities. Autonomous maintenance. Autonomous maintenance is the carrying out of maintenance activities by machine operators in close coordination with maintenance department. Autonomous maintenance by operators is one of the primary features of total productive maintenance and is key point in its environment development. In autonomous maintenance, the operators learn to carry out the housekeeping and maintain a basic equipment conditions, that is lubrication, adjustment, minor repairs, etc. With this, we conclude this session.